In this video, we're going to go over the solutions to the Paper 1 exam from the May 2022 Timezone 1 examination. Let's go ahead and start looking at number 1. In question number 1, the maximum marks is 5 points. The front view of a doghouse is made up of a square with an isosceles triangle on top. The doghouse is 1.35 meters high and 0.9 meters wide and sits on a square base. The top of the rectangular surfaces of the roof of the doghouse are to be painted. Find the area to be painted. Okay, so there's a lot of information going on here, and this is actually the first question of this examination for this year. Let's go back to the information and underline important things. It says the front view of a doghouse is made up of a square with an isosceles triangle on top. So right now I know that this is an isosceles triangle on top, isosceles meaning both of these sides are the same. And here at the bottom, I know that this is going to be a square because it says that the doghouse is made up of a square with an isosceles triangle on top. So in a square, all four sides are the same. If they tell me this length is going to be 0.9, that means that the height right here in blue is also going to be 0.9. Notice that in the diagram, they have told me the entire height of the doghouse. So basically going the entire way up is going to be 1.35, which means that in order for me to figure out the height of this isosceles triangle, I am going to have to subtract 1.35 minus 0.9, and that's going to give me 0.45. On the mark scheme, out of these 5 possible marks, you would get 1 mark just for identifying that the height of that triangle is 0.45. So the other thing is, let's find out what it is that we're trying to find the area of. It says the top of the rectangular surfaces of the roof of the doghouse are to be painted. So what's going to be painted basically are 2 of these. And I know that I basically have to find the area of one of those rectangles, and then I'm going to have to multiply it by 2. Important dimensions that I know, this is 0.9, so this is also going to be 0.9. Now be careful. We figured out the height of this isosceles triangle is going to be 0.45. You cannot assume that the hypotenuse of that triangle is going to be 0.45. Instead, what I know is that half of 0.9 is going to be 0.45. So in this right triangle right here, if I were to redraw it, what I have is that this is 0.45. Now this half is also 0.45. This is an isosceles triangle. So I have basically a 45, 45, 90 triangle, which means that I can figure out the hypotenuse of the triangle by either using the information that I know about special right triangles, which is that in a 45, 45, 90 triangle, to go from one leg to the hypotenuse, you're going to basically have to multiply by the square root of 2. So I know that this hypotenuse is 0.45 times the square root of 2. And if you don't remember that, that's perfectly fine because you can just use the Pythagorean theorem and then you can figure out that answer. According to the Pythagorean theorem, I'm going to do 0.45 squared plus 0.45 squared is going to equal 2c squared. So if you take your calculator and do 0.45 squared plus 0.45 squared, you're going to get 0.405 is equal to c squared. Remember to take the square root of that number. You're going to get approximately 0.6363961 is going to be the hypotenuse. And notice that I don't want to round to 3 significant figures right now. Why? Because I want to avoid round off error. So if I know that that's 0.45 times the square root of 2, that is the best answer for me to use because that is not going to have round off error. But in the case that you want to go ahead and use the decimal, I would go ahead and use like 5 or 6 decimal places and wait to round until the very end of my calculations. So what I have so far is this rectangle, which is the one that I've shaded in purple. And I know that the length is going to be 0.9. And I just figured out that this width, which is the hypotenuse of my triangle, is going to be 0.45 square root of 2. And remember, that's approximately equal to 0.6363961. So you can use that number as well. So to figure out the area of one rectangle right here, then I'm simply going to multiply 0.9 times 0.45 times the square root of 2. That's going to give me 0.405 times the square root of 2, which is approximately equal to 0.572756, blah, blah, blah. But remember that there are two of these, so I'm going to have to multiply this by 2 because there are two rectangles. So if I multiply by 2, then I'm going to get 1.1455129, blah, blah, blah. And this is going to round to approximately 1.15. And then the units, because it's meters, then area is going to be square meters. And this is going to be my final answer. On the IB exam, you'd want to write all your work right here, and these spaces, I have written it basically next to the picture because I want to be able to show you exactly what I'm doing, but you would actually have to take the time to put it on your paper. Okay, so let's move on to question number 2. A vertical pole stands on horizontal ground. The bottom of the pole is taken as the origin, O, of a coordinate system in which the top F of the pole has coordinates 0, 0, 5.8. All units are in meters. The pole is held in place by ropes attached at F. One of the ropes is attached to the ground at point A with the coordinates 3.2, 4.50. The rope forms a straight line from A to F. Part A, find the length of the rope connecting A to F. When they say length and they give you coordinates, then you know that you're going to have to find this by using the distance formula. So length is associated with the distance formula. In this case, notice that you have 3 values. You don't have 2 values like in an ordered pair. So what you have to do is find the formula from your formula packet. When you find the formula in the formula packet, it's going to tell you that the distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. Okay? And so you are never going to get any points on the IB exam for just copying down a formula. What you need to do is go ahead and substitute into the formula. If you want to find the distance from A to F, that means that I want to use these ordered pairs right here. So I'm going to go ahead and substitute, and I'm going to say that this is equal to 3.2 minus 0 squared plus 4.5 minus 0 squared plus 0 minus 5.8 squared. This can now go into your calculator. 3.2 squared is going to be 10.24 plus 4.5 squared is 20.25 plus 5.8 squared is 33.64. Now I add this all together and I take the square root, and I'm going to get 8.00812 as my answer, which is going to be rounded to 3 significant figures at approximately 8.01. It is always a very good idea to write the entire decimal answer, or at least 5-6 decimal places, and then round to 3 significant figures unless they tell you otherwise. So now our job is to go ahead and move on to part B. In part B, it says find the measurement of angle FAO. So angle FAO is this angle right here. I'm going to call it theta. The angle the rope makes with the ground. So that is our job right now. We just figured out that this distance is 8.01. So the other thing that we can do is either find the distance from F to O, and then I can use the trig ratio there, or I can just find the distance from O to A, and I can use that trig ratio there, which means that you're going to have to do this whole distance formula one more time. It's going to be easy either way because the point on the ground for O is 0, 0, 0. So let's go ahead, and if I were to find this one right here, for example, the distance here is going to be the square root of 3.2 minus 0 squared plus 4.5 minus 0 squared plus 0 minus 0 squared. So this is going to be about 5.52. If instead on the exam you wanted to find from F to the ground, the pole, the height of the pole, it would be about 5.8. And again, you're doing this the same exact way by putting it into the formula. So I have options now in terms of finding this angle. To find the angle, and remember to label your work. So that was for part A. So now for part B, I can go ahead and say, well, if this is theta, this of course is my hypotenuse. I can work with the 5.52, which is going to be my adjacent side. The relationship in SOHCAHTOA between adjacent and hypotenuse is going to be cosine. So I can say that the cosine of theta is equal to adjacent over hypotenuse. And this basically means that I can find theta by doing the arc sine of 5.52 divided by 8.01, which basically just means that in your calculator, you're going to press second cosine. This is on a TI 84, 5.52 divided by 8.01, and you're going to get 46.43804, etc., which then rounds to about 46.4 degrees. So that is going to be my final answer. Another way that you could do the problem, because in case you figured out the height, is that you can do sine. So on the exam, only choose one way of doing this. Do not do it more than one way, unless they ask you to, of course. In this particular case, though, I'm going to show you two ways in case you use the other part. So the sine is going to be 5.8 over 8.01. So the sine of theta is equal to 5.8 over 8.01. Same thing, you're going to do the arc sine of 5.8 divided by 8.01. Then you go to your calculator, second sine 5.8 divided by 8.01, and you're going to get exactly the same thing. This is about 46.4 degrees, and that's the final answer. Okay, let's head on over to question number 3. It says the height of a baseball after it is hit by a bat is modeled by the function h of t equals negative 4.8 t squared plus 21t plus 1.2, where h of t is the height in meters above the ground and t is the time in seconds after the ball was hit. Part A, write down the height of the ball above the ground at the instant it is hit by the bat. Two things you need to notice. Number one, this is a 1-point question. It's supposed to be very easy. And number two, the directions say to write down, which again means that it's supposed to be super easy. For 1-point questions, you don't really have to show like the work or explanation, because you're either going to get the point or you're not going to get the point. In this particular case, if you want to write down the height of the ball above the ground at the instant it is hit by the bat, that is at time 0. So you're going to find h of 0 by basically substituting 0 into the equation. So that's going to just give me 1.2 as my final answer. Then I go ahead and look at part B. Find the value of t when the ball hits the ground. When is the ball going to hit the ground? When the height is 0. So in part A, you're substituting 0 for t, but in part B, you're substituting the height, basically the answer. You want to solve for when this is equal to 0. And one of the important things to realize is that they will give you, from those 2 marks, 1 mark right now just for setting up the equation equal to 0, even if you don't know how to solve it. So how do you solve this? Well, you have a choice. You can either go to the graphic display calculator, where you can enter y1 as the equation negative 4.8 t squared plus 21t plus 1.2. And remember that on the calculator, it's going to be x. It's not going to be t. Then you can make y2 0. And then you can go to, actually see if you can go to zoom fit so that you can see both of those. You're going to go to second trace, which are your calculations. You're going to go to option 5, which is intersect. And then you're going to figure out that the solution is x is equal to 4.43. So let me show you really quickly what that looks like on a calculator. You go to y equals, I'm going to enter negative 4.8x squared plus 21x plus 1.2. Then I'm going to come down to y2 and I'm going to make that equal to 0. I'm going to go to zoom fit, which is option 0, to see if I can see it. And that's perfect. That's exactly what I want. Notice that I can see my red line, which is y equals 0. And then I see the upside down parabola, which is what I expected. And all I care about is when are they equal to each other. So there's going to be two places where the line intersects the parabola. We want the positive answer, not the negative answer. Remember that this is basically a word problem where it only makes sense for the ball to hit the ground in a positive time. It doesn't make any sense to go back in time, okay? So you're going to not care for the negative answer, you want the positive answer. So I'm going to go to second, trace. I'm going to go to option 5, which is intersect. I'm going to head on over to this other point right here, and I'm going to press enter 3 times, okay? And the intersection is going to be 4.43. So once again, I go second, trace, option 5, which is intersect. You want to basically just use the left and right arrow to move the cursor close to the answer you want, and that's the place that I'm looking for. Where does that intersect? I press enter. It's going to ask me where is the second curve. Press enter again. It's going to ask you to guess. Press enter again. So enter 3 times. And then 4.43 is going to be my final answer. So that is definitely one way that you can do this problem. The other way that you can solve it, of course, is by using the quadratic formula. And you would have to look at the quadratic formula. It is in the formula packet. You're going to say t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. It's going to take you a little bit longer because you're going to have to substitute everything in here. So basically you're going to have negative b, which is 21. So negative 21 plus or minus the square root of 21 squared minus 4 times negative 4.8 times c, which is 1.2, all over 2 times negative 4.8. So I set up the problem. Now that I've set up the problem, I have to put this all in my calculator, and it's going to give me 2 answers. One answer is negative 0.0564. The other one is going to be 4.4314. And obviously the answer that we want is a 4.43 positive answer because the other one we don't really care for. So that is an extraneous solution, a solution that algebraically you get, but it doesn't make any sense with the answer that we're working with right now. So then that is going to be the answer for part B. Finally, for part C, it says state an appropriate domain for t in this model. What is domain? So in terms of, and I'm going to find a little space here for you. So basically this is the idea. You're going to graph this. The height of the baseball at time 0 is at 1.2. The baseball is going to go up and then it's going to come right back down. This function is time versus height. Domain is what's on your x-axis, your input. So in this case, time is domain. So when it says what is an appropriate domain for t in this model, well, you're starting at time 0. So for part C, an appropriate domain is going to be from 0 less than or equal to t less than or equal to. Remember, when does the ball hit the ground? We just found out that the ball hits the ground at 4.43 seconds. So then 4.43 is going to be my answer. You can write it as an inequality or you can write it in interval notation, 0, 4.43 with the brackets because it can be 0 at time 0. Remember, the height of the ball is at 1.2. And then the ball is going to hit the ground at 4.43. So that is going to be my domain. All right, so let's take a look at question number 4. 3 towns A, B, and C are represented as coordinates on a map where the x and y axes represent the distances east and north of an origin, respectively measured in kilometers. Town A is located at -6, -1, and town B is located at 8,6. A road runs along the perpendicular bisector. I'm going to already underline that because I know that's going to be important. Of AB. This information is shown in the following diagram. It says for part A, find the equation of the line that the road follows. That is a 5-point question. So when you see a 5-point question, there's a lot of work involved in this question. Find the equation of the line that the road follows. Let's go back. Town A is located at -6, -1. Here's town A. Town B is located at 8,6. A road runs along the perpendicular bisector of AB. So here is the road, and it runs along the perpendicular bisector of AB. That is important. The perpendicular bisector requires that you find the midpoint because it has to go through the center, because that's what bisector means. You're going to have to find the slope, which is called the gradient for IB. And because it's perpendicular, you're going to have to find the perpendicular slope. Remember, the upside down T is the symbol for perpendicular. So already right there, you're going to start getting a lot of points. You're going to get 1 point for sure for finding the midpoint. You're going to get 1 point for finding the slope. You're going to get 1 point for finding the perpendicular slope. And then you're going to get another point for finding the equation of the line. And as a matter of fact, when I looked at the mark scheme for this question, they gave you 2 points for the slope. So that's actually a lot of points that you want to make sure that you get on this one particular question. So let's go ahead and start by finding the midpoint. Doesn't matter the order in which you do midpoint or slope. Not really, you could have done slope first, but I'm just going to go ahead and start by finding the midpoint. Again, it is the perpendicular bisector, so the road has to go through the midpoint, okay, of that line segment. So to find the midpoint, I'm going to get the average of these x coordinates divided by 2, comma -1 plus 6 divided by 2. A few things to realize. Notice how I'm writing this as a point, as an ordered pair. -6 plus 8 is positive 2 over 2. Then -1 plus 6 is positive 5 over 2. So my midpoint is the point 1, comma 2.5. So I can go ahead now and leave that as my answer. That would have given me 1 point. Now the next thing that I want to do is figure out the slope, the gradient. So to figure out the gradient, remember it's y2 minus y1 over x2 minus x1. This formula is in the formula packet, so you have to get it correct. So the y's, it's always x comma y. So it's x, y, x, y. So you just have to be consistent. 6 minus -1 all over 8 minus -6. Negative is a positive. So I have 7 over 14, which is equal to 1/2. So that is going to equal to 1/2. In terms of the perpendicular slope, I know that I have to do the negative reciprocal, which is to flip it. And then after I flip it, change the sign. So this is going to become -2 over 1. So right here, just with what you have done, you would have gotten 1 mark for the midpoint, 2 marks for the slope, another mark for the perpendicular slope. You already have 4 points. Let's go ahead and finish the problem. Now I have to find the equation of the line. This line has to go through the midpoint with this slope right here. So I'm going to write y equals mx plus c. The y value, I'm going to use the y coordinate, 2.5. For m, it's -2, which is the perpendicular slope. For x, I replace it with 1 plus c. 2.5 is equal to -2 plus c. Add 2 to both sides, and I'm going to get 4.5 is c. So the equation becomes y equals -2x plus 4.5, and that is going to be my final answer. They haven't asked for standard form, so I can leave it like that. Those of you who like point slope form, you can also leave it in point slope form. So that's the answer for part A. For part B, it says the town C is due north of town A. Due north means directly above. So notice it says town C is basically directly above, due north of town A, and the road passes through town C. Find the coordinate of town C. Because town C is due north of town A, that means that the x coordinate at town C is also going to be -6. So my job right now is to find the y coordinate of town C. And that I'm going to do by substituting it into the equation of the line that I just found. So to figure out that y value, I'm going to substitute -6 for x. My equation is y equals -2x plus 4.5. as long as you show your work with the equation that you found, even if it's incorrect, you would get follow-through credit if you show your work. So if you're showing how you are substituting -6 into your equation, you're going to get follow-through marks, which means that you're going to get the full marks. So y equals 12 plus 4.5. So y equals 16.5. And that is your final answer. Be careful not to write this as an ordered pair. The minute you write this as a point -6, 16.5, you lose that second point. You only get 1 mark, not 2 marks, because the question is only asking you for the y coordinate. And that's something that's really important to point out, because that's exactly how you would lose a point. You're excited because you figured out how to do the problem, but then you wouldn't even realize that you didn't get those full 2 marks because you actually wrote it as an ordered pair. So the correct answer is 16.5. On to question number 5. In question number 5, you have the ticket prices for a concert are shown in the following table. A total of 600 tickets were sold. The total amount of money from ticket sales was $7,816. There were twice as many adult tickets sold as child tickets. Let the number of adult tickets sold be X, the number of child tickets sold be Y, and the number of student tickets sold be Z. So we have X, Y, and Z. It says write down 3 equations that express the information given above. Okay, they give us 3 bullet points, and they ask us for 3 equations for 3 marks, which is easy to tell that it's going to be 1 mark per equation. The first one says a total of 600 tickets were sold. That means the number of adult tickets plus the number of child tickets plus the number of student tickets in total is going to be 600. That is going to be my first equation. This is basically just a system of equations. You should have done this not only in your IB class, but in Algebra 2. Then the second one says the total amount of money. So we have how many and now how much. Each adult ticket costs $15. So 15x plus each child ticket costs $10 plus 10y plus each student ticket costs $12. And that's a total of $7,816. So that's my second equation. Then my third equation, there were twice as many adult tickets sold as child tickets. So here, either x is equal to 2y or y equals 2x. And you have to figure out which one is correct. Well, let's take a look at the first one. X is the number of adults. If I sold 4 adults, that means I would have sold 2 children. Does that make sense? There were twice as many adult tickets sold as child tickets. So if I sold 2 children's tickets, then I have 4 adults. That makes sense. That is twice as many. Let's try it in y equals 2x. Here, y is the child. So if I sold 2 children's, that means that I would have sold 4 adults. And that would have meant that 2 equals 8. And 2 does not equal 8. So that doesn't make sense. So this is actually going to be my final equation. X is equal to 2y. There were twice as many adult tickets as child tickets. So x equals 2y. What do I do with this information? Now in part B, I'm supposed to solve so that I can find the number of each ticket sold. So what I'm going to do now is take those 3 equations. I'm going to start with x equals 2y, and I'm going to substitute. So that means that instead of x in my first equation, I'm going to write 2y plus y plus z is equal to 600. That means 3y plus z is equal to 600. So z is equal to 600 minus 3y. So that's one of the things that I can do to get the z by itself. Now I'm going to take the other equation and I'm going to substitute into this equation. So I have 15 times x, but remember that x is equal to 2y. So I have 15 times 2y plus 10 times y plus 12 times z. But z, if you remember, we just found out, is 600 minus 3y. So I'm going to replace this with 600 minus 3y is going to equal 7,816. I'm going to go ahead and multiply everything out. I get 30y plus 10y plus 12 times 600, which is 7,200, minus 36y, because you are distributing, is equal to 7,816. Go ahead and combine like terms. 30y plus 10y is 40y. 40y minus 36y is 4y. I can go ahead and subtract 7,200 from both sides. That cancels on the left. Bring down your equal sign. So that's going to equal 616 divided by 4. So that tells me that y is equal to 154. And y, if you remember, represents the number of child tickets. So y is equal to 154. Then I can go back and I can substitute. X is equal to 2 times y. So 2 times 154, which is going to be 308. So x is equal to 308. And then z is equal to 600 minus 3 times y, which is 154. So that's going to equal 138. So z is equal to 138, and those are going to be my 3 answers. So then we go on to question number 6. It says a modern art painting is contained in a square frame. That's probably going to become important. That's a square. The painting has a shaded region bounded by a smooth curve and a horizontal line. When the painting is placed on a coordinate axis such that the bottom left corner of the painting has coordinates -1, -1, and the top right corner has coordinates 2, 2, the curve can be modeled by y equals f of x, and the horizontal line can be modeled by the x-axis. Distances are measured in meters. Use the trapezoidal rule. So ding, 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 we found it. This is basically the concept they're going to be testing us on in this question. It's the trapezoidal rule, with the values given in the following table to approximate the area of the shaded region. Okay, so very clearly, this problem is on the trapezoidal rule, which means that at this point, you're going to go to your formula booklet. You're going to go to topic 5. Remember that your formula booklet is organized by topics, and calculus is topic 5. You're going to find the trapezoidal rule, which says that the integral from a to b of y dx is approximately equal to, and here is the trapezoidal rule. It's 1/2 the height times y naught plus yn, which are your inner and outer bases, plus 2 times the sum of all the other bases. So what does that mean in terms of this problem? So here, because they give you this table, it's the best case scenario. You can figure out that the height of each one of my trapezoids is going to be 1. In order for me to find this answer with the trapezoidal rule, it's going to equal 1/2 the height, which is 1, because notice that each trapezoid is going to be going by 1. And then I'm going to take the first base, which is 0.6, add it to the last base. So 0.6 plus 0 plus 2 times the inner bases. So it's going to be 2 times 1.2 plus 1.2. So all I'm doing is following exactly what the trapezoidal rule says from the formula packet. And so then I'm going to put this all into my calculator. 1.2 plus 1.2 is 2.4. 2.4 times 2 is going to give me 4.8. So this is going to equal 2.7 square meters. All of that goes straight into your calculator. So you're going to get 3 points right there. One of the points is going to be for identifying the height is equal to 1. The second point is for the work into substitution into the trapezoidal rule. And obviously the last point is going to be for your correct answer of 2.7 square meters. Then it says, the artist used the equation to draw the curve. Find the exact area of the shaded region. To find the exact area, you're going to have to use your calculator to go ahead and figure out the integral from -1 to 2 of this equation of basically y dx, okay? So in the calculator, you're going to have to go to math 9 to put in the integral so that you put in all this information. Basically, you want to find the integral from -1 to 2 of this entire equation, -x cubed minus 3x squared plus 4x plus 12 all over 10 dx. Don't forget the dx, very important because that means with respect to x. So let's go ahead and go to the calculator, and then you're going to copy down exactly what the calculator gives you because they say they want the exact area. Okay, so once you're in the calculator, you're going to go to math. You're going to come all the way down to number 9, which is your finite integral. You're going to enter the lower bound as -1. The upper bound is 2. And now you're going to enter the entire equation that they gave you, which looks like a fraction. So I'm going to go to alpha y equals to put this as a fraction so I don't make a mistake. And I'm going to type it exactly as I see it. -x to the third minus 3x squared plus 4x plus 12 all over 10. And this is going to be dx. So notice right there, the calculator is giving you the exact answer, 2.925. So the answer for part B is going to be 2.925 square meters. If you round that, you're not going to get the final point because the question says to find the exact area. Now for part C, it says to find the area of the unshaded region. If we take a look at the picture they gave us, by finding the integral, we were able to determine that everything that is shaded, this area is 2.925. So to figure out the unshaded area, we have to remember that this is basically just a square. They told us that. And notice that my values here are from -1 to 2 because the height here is 2. So this is basically a 3 by 3 square. And again, how did I get that? Because of the points of the ordered pair. 2 minus -1, minus is a plus, so that's just equal to 3. And if I do the same thing here, I know that this is a 3 by 3 square. So to figure out the area of the unshaded region is basically 3 times 3, which is 9, minus the area of the region that was already shaded. So this means 9 minus 2.925. This answer is going to be 6.075 square meters, and they haven't told me how to round, so I can go ahead and leave it as 3 significant figures. So number 7, Leo is investigating whether a 6-sided die is fair. He rolls the die 60 times and records the observed frequencies in the following table. Leo carries out a chi-square goodness of fit test at a 5% significance level. Write down the null and alternative hypotheses. That is only 1 mark for both of them. So for part A, you want to make sure that you identify which one is your null and which one is your alternative hypothesis. The null hypothesis is H with an O, H naught. So you can write the die is fair. So the null hypothesis is there's nothing going on, the die is fair. The alternative hypothesis is that the die is not fair. You could have also written that the probability of any number is 1/6 for the null hypothesis. Other acceptable answers for the null hypothesis is that all the probabilities are equal, and then the alternative hypothesis would be the probabilities are not equal. You could also have written that the null hypothesis is that the probability of choosing any number is 1/6, and that the alternative hypothesis is that the probability of choosing any number is not 1/6. Then for part B, it says to write down the degrees of freedom. In a chi-square goodness of fit test, the degrees of freedom is equal to n minus 1. So the number of columns is 1, 2, 3, 4, 5, 6. So that means that my degrees of freedom is going to equal 6 minus 1, which is 5. That is also a 1-point question. So I didn't even have to show the work. I could have just written 5. For part C, write down the expected frequency of rolling a 1. The probability that you roll a 1, okay, so the probability that you roll a 1 is going to be 1 out of 6 because one side is going to have the number 1 out of 6 sides. But here, remember that you're rolling this 60 times. So 1/6 times 60, that means that I would expect 10 times to roll the number 1 if in fact this is fair, because the probability is 1/6. So to write down the expected frequency of rolling a number 1, you basically have to multiply the probability times the total number of times that you're doing the trials, the experiment. So in this case, it's 1/6 times 60. For part D, to find the value for the test, this is where you're going to have to go to your calculator. You're going to go to Stat, Edit, and this is not something you would actually write on the exam. I'm writing it for you so that you know where to go on the calculator. Under list 1, you're going to list the observed frequencies, which are the numbers 8, 7, 6, 15, 12, and 12. 8, 7, 6, 15, 12, and 12. And then your list 2 are going to be your expected values, which again, our expected values are going to be 10 for each time we roll any number, because we are assuming that we have a fair die. So you're going to put this into your calculator, then you're going to go to Stat, you're going to go all the way to Tests, you're going to go find chi-square goodness of fit test, and that's how you're going to be able to find the p-value for this question. So we're going to go to the calculator, you're going to go to Stat, Edit, List 1, you're going to enter all of the observed values, 8, enter 7, enter 6, enter 15, enter 12, and 12. Then you're going to go to List 2 and you're going to put in the expected values, 10, all the way down, because the expected value for each one is going to be 10. Make sure that your dimensions match, okay? Then Stat, go over to Tests. You're going to find the chi-square goodness of fit. I'm going backwards. I'm going up because it's shorter. So the goodness of fit is the GOF, chi-square goodness of fit, option D. Press enter. It's going to ask you, where did you put the observed list? List 1. Where's the expected list? List 2. The degrees of freedom is 5. And then the choices of blue, I mean, that's just your personal choice. Press calculate. And so the p-value is 0.28724. So I'm going to write 0.28724 ... which I'm then going to round to 0.287. So that right there is going to be worth 2 marks. Finally, it says to state the conclusion of the test and give a reason for your answer. If you go back, you're going to realize that we are doing this at a 5% significance level. You are going to compare your significance level to your p-value. So the answer to part E is that since your p-value of 0.287 is greater than your significance level of 5%, then you fail to reject your null hypothesis. That means you accept your null hypothesis. And that means that if you fail to reject the null hypothesis, you conclude that the die is fair. Okay, so now let's go on to question number 8. In question number 8, it says a factory produces bags of sugar with a labeled weight of 500 grams. The weights of the bags are normally distributed with a mean of 500 grams and a standard deviation of 3 grams. So this is a normal distribution problem. They tell me the mean is 500, the standard deviation is 3. So X is normally distributed, the mean is 500, the standard deviation is 3. This is just how you write the distribution. They're not asking you to do that. I'm doing it just as a review. Then it says part A, write down the percentage of bags that weigh more than 500. That is only a 1-point question. It's supposed to be very easy. Do realize these are normal distribution problems. In the normal curve, my mean is going to basically be straight down the middle. That's 500. So it says write down the percentage of bags that weigh more than 500. This right here is going to be 50%. And what's really important for you to notice about the exam is the way they're asking you the question. This is only a 1-point question, and they very clearly are asking you for the percentage. If you were to write down 0.5 or 1/2, you will not get the points for this question. I know, it kind of hurts because you do understand that it's 0.5. The probability is 0.5. But because they were very specific that they want the percentage of bags, they are not going to accept 0.5 or 1/2 for this answer. Then it says a bag that weighs less than 495 grams is rejected by the factory for being underweight. Find the probability that a randomly chosen bag is rejected for being underweight. So for part B, again, doing a sketch is a really good idea for you to get some type of partial credit. So this in the middle is the mean. This is 500. And it says that any bag under 495 is rejected by the factory. 495 is somewhere to the left of 500. And any bag that is less than that, okay, so I'm going to shade all of this, is going to be rejected by the factory. So my job is going to be to figure out exactly how much am I shading. Okay, so what is the percentage that I'm shading? Notice that it's less than 50%, so I expect my answer to be less than 50%. So it says find the probability a randomly chosen bag is rejected. So the way it is rejected is if it weighs less than 495 grams. How do I do this on my calculator? You're going to go to your calculator. You're going to go to second vars, option 2, which is normal CDF. This is not something that you need to write on your exam. As a matter of fact, it is a waste of time. Do not write these calculator steps on your paper for the exam. I'm writing them down for you so that you remember how to do this. So you're going to go to the calculator. It's going to prompt you for the lower bound, which is negative infinity. You can enter negative infinity as -1 E99. Remember, this E is for exponential notation, so it's going to be second, comma, basically. Then it's going to ask you for the upper bound. In this case, anything lower than 495. So my upper bound is 495. The mean is 500. And the standard deviation is going to be 3. For those of you who have a graphing calculator that's a little bit older and perhaps is not prompting you to give lower, upper, mean, standard deviation, you're going to have to memorize that order. And so you're going to go to second vars, option 2, normal CDF, and you're going to have to just enter all of those values separated by a comma. So in your calculator, you're going to go second vars, option 2, which is normal CDF. Here, it already has it by default to negative infinity, which is great because I don't have to do anything. Remember, your calculators are cleared before you test. So that is fantastic that by default, it'll be there, negative infinity, in case you forget. The lower bound is negative infinity. The upper bound is 495. The mean is 500. And the standard deviation is 3. So now you go to paste, press enter, and that's your answer. Be careful because a lot of students mess up when there's zeros in the very front of that decimal. It is 0.04779. Always write 5 or 6 decimal places and then round to 3 significant figures unless they tell you otherwise. So on my paper, I'm going to write down that the answer is 0.047793 ... which is approximately 0.0478 when I round to 3 significant figures, and that's my final answer. In part C, it says a bag that weighs more than K grams is rejected by the factory for being overweight. The factory rejects 2% of bags for being overweight. Find the value of K. Once again, I'm going to draw a little sketch to show what it is that is happening. Here is the mean, which is 500. In this case, the factory is going to reject 2% of the bags for being overweight, and it is our job to figure out that weight. So this is one of those inverse norms problem where this right here represents 2%. So this is 0.02. I go to the calculator, second vars, this time option 3, inverse norm. And it's inverse norm because I know the area. I'm trying to figure out the actual value. Okay, what is the actual weight? I want to figure out what is that K. So the area is going to be 0.02. The mean is 500. The standard deviation hasn't changed, is 3. And this time it is tailed right. There might be some of you that don't have the option of tail right, which means that your calculator is only tail left. If that is the case, then instead of finding the probability that x is greater than k is 0.02, you're going to go backwards to find the probability that it's less than at 0.98. So in other words, the complete opposite of everything that's not shaded that I just kind of did right now in red, that all of that is going to be 1 minus 0.02, which is 0.98. So I would be looking at 0.98 area if it were to the left, or just 0.02 if it's to the right. So on the calculator, you're going to go second, vars, option 3, which is inverse norm. The area is 0.02, the mean is 500, the standard deviation is 3, and it is tail right. So you're going to press enter, then go down to paste. And so the answer is 506.1612467. For those of you who don't have the option of tail right, tail left, your calculator only works left. So you would go second vars, option 3 inverse norm. The area you're going to use is 0.98. Now, I'm going to pretend like none of this is being asked. Your calculator by default would have been set to the left, but notice that you're going to get exactly the same answer because you told the calculator the area that would have been shaded on the left. So then this answer is basically going to be 506.1612467 ... I always like to write my full answer, and then I'm going to round to 3 significant figures, and don't forget your unit. Okay, for question number 9, this is definitely a calculus question because I can tell by looking at part A with the notation that means to find the derivative. It says the function f is defined by f of x equals 2 over x plus 3x squared minus 3, where x is not equal to 0. Find f prime of x. That means find the derivative. That is a 3-mark question. You need to know how to find the derivative. First of all, I need to take the time to rewrite this problem right here. 2 over x means 2x to the negative 1 power. Then all I'm doing is rewriting the problem. Realize that on the exam, they would have given you 1 mark just for writing that as x to the negative 1 power. Now I can go ahead and actually take the derivative. So for part A, the derivative is going to be, remember to use the power rule. You take the power, you multiply to the number in front, reduce the power by 1. So I'm going to get negative 2x to the negative 2 power, because negative 1 minus 1 is negative 2, plus, do it again, you're going to get 2 times 3, reduce the power by 1. So it's going to be 6x to the 1 power. You don't have to write the 1 power. And then the derivative of a constant is just 0. So that is my final answer. You would have gotten 3 points for that answer. If you don't know how to find the derivative for the 2x to the negative 1, just by writing the 6x would have given you 1 mark. And remember, this exam is about getting every possible mark. Then for part B, it says to find the equation of the normal to the curve. As a reminder, when you have any curve, you have a tangent line, which basically only touches the graph 1 time. The normal is perpendicular to that tangent. So what you're doing is trying to figure out the equation of that line, which is perpendicular to the tangent line. The slope of the tangent line is your derivative. So one of the important things for us to do right now is that we're going to have to substitute the 1 into our derivative so that way we can figure out what is the slope at that point. And this, by the way, is not necessarily how this graph looks. I just did a random curve to kind of explain to you what the difference between tangent and normal is. So for part B, I'm going to go ahead and substitute f prime of 1. So I'm going to substitute 1 for every x in my derivative. So negative 2, that really means over x squared. So over 1 squared plus 6 times 1. This becomes negative 2 over 1 squared is negative 2 plus 6 is equal to 4. The perpendicular slope to positive 4 is negative 1/4. And it has to pass through the point 1, 2. So now I'm ready to figure out the equation of the normal. Y equals mx plus c. 2 is equal to negative 1/4 times x plus c, which is what I'm looking for. So I get 2 equals negative 1/4 plus c. Go ahead and add 1/4 to both sides. So 2 and 1/4 is the same as 2.25. Or to write it as a fraction, it basically becomes 9/4. And this is something that you can do in your calculator. But if you realize that would have only given you 3 out of the 4 marks, and that is because they want this in standard form. In order for you to write the equation now, basically I get y is equal to negative 1/4 x plus 9/4. But in standard form, I'm going to have to multiply everything by the least common denominator, which is 4, because you can't have any fractions. You can't have an x that is negative, and all of it has to be set equal to 0. So 4y is equal to negative x plus 9, because the 4's would have canceled. And you want to set this equal to 0 so that you have it in the appropriate form. So you have positive x plus 4y minus 9 equals 0. And here, this would have been my final answer for your 4 marks. All right, so let's go to number 10, which is a probability question. I can tell by looking at the tree diagram. Carl has 3 brown socks and 4 black socks in his drawer. He takes 2 socks at random from the drawer. Complete the tree diagram. Okay, so this tells me 3 out of 7 of his socks are brown, which means 4 out of 7 are black. So remember, these have to add up to 1. If he takes a brown sock the first time, that means he has 1 less brown and 1 less sock in total. That still leaves him with 4 out of 6 socks that are black. If he has 4 out of 7 socks that are black, then if one of them is black, the probability the second one is going to be brown is 3 out of 6, because he still has 3 brown socks out of 6 now in total. And the probability that he chooses another black sock is still going to be 3/6, because it's 1 less black sock out of the total now of 6 socks. So that's going to give you 1 mark for both of those answers being correct. Find the probability Carl takes 2 socks of the same color. Let's think about how that can happen. So for part B, Carl can find black and black, or, which in probability or is plus, he could get brown and brown. So the probability that he gets black and then black again is 4/7 times 3/6. Even if you would have messed up a little bit on your probability tree diagram, if you show your work correctly, you will get follow-through marks for this part. So black and then black again is 4/7 times 3/6 plus, then the probability that you get brown is 3/7 and brown again 2/6. So plus 3/7 times 2/6. So this is 12/42 plus 6/42, which is 18/42. And you can leave the answer like that. You will still get full credit. Or you can reduce this to 3/7. You can even divide, and this is about 0.429. Any of those answers are going to be acceptable for your 2 marks. For part C, given that Carl, so the minute I see given, it makes me feel like this is going to be a conditional probability problem, but I'm going to read the whole thing first before I decide. Given that Carl has 2 socks of the same color, find the probability he has 2 brown socks. And sure enough, this is an example of conditional probability. There is a formula for conditional probability. It is in your formula packet. The way conditional probability works is that you want the probability that he has 2 brown socks given that he picked 2 of the same color socks. So this is equal to the probability of the intersection. In which way is he going to get 2 brown socks and 2 socks of the same color? That is going to be 3/7 times 2/6 all over the probability that he got the same color socks. And I just found out that probability from the previous answer in part B, which is 3 over 7. So this is over 3 over 7. So this is going to be 6 over 42 over 3 over 7, or you could have just realized these are going to cancel, right? So the answer is 2 over 6, but it's okay. We're going to continue with the math. So 6 over 42 divided by 3 over 7. This is basically 6 over 42 times the reciprocal. And then I can go ahead and simplify. This becomes 1, 2. This is 1, 6. So the answer is 2 over 6, or 1/3. And so that's going to be your final answer for your 3 marks. All right, let's look at number 11. The strength of earthquakes is measured on the Richter magnitude scale with values typically between 0 and 8, where 8 is the most severe. The Gutenberg-Richter equation gives the average number of earthquakes per year, N. So you know that's going to be important. So I'm going to go ahead and underline. N is the average number of earthquakes per year, which have a magnitude of at least M. So the magnitude is going to be M. For a particular region, the equation is log base 10 of N equals A minus M for some A in the real numbers. This region has an average of 100 earthquakes per year with a magnitude of at least 3. Find the value of A. Okay, so very easy right now for part A. I'm going to copy over the equation they give us, the log base 10 of N, where N is the average number of earthquakes per year. So in this particular example, N is 100. So 100 is equal to A minus M, where M is magnitude. So the magnitude is at least 3. Just for writing this down, you are going to get 1 point. Now, this is something that you can put into your calculator. If you don't know what the log base 10 of 100 is, which the answer is 2, because this means 10 to what power is 100. But let's say that you don't know that, which is fine. You can go to your calculator on the TI-84. You can go to math. You can now go to part A, which is log base. And then you can enter the log base 10 of 100, and it's going to tell you that that's equal to 2. So this means that 2 is equal to A minus 3. And if you add 3 to both sides, that means that A is equal to 5, and that's the answer. So in the calculator, you go to math. You're going to go to the letter A. So you're going to keep on scrolling down until you get to A, which is log base. And now you're going to put base 10 of 100, which is equal to 2. For part B, the equation for this region can also be written as N equals B over 10 to the M power. Find the value of B. Okay, so I'm going to write down N is equal to B over 10 to the M power, and I'm going to replace it with the information that I know, which is that N, in this case, is 100 and M is 3. So I'm going to write down 100 is equal to B divided by 10 to the 3rd power. So now take your calculator, do 100 times 10 to the 3rd power, and that's going to give you 100,000 is equal to B, and that's going to give you your 2 points. For part C, it says, given that 0 is less than M less than 8, find the range for N. Well, basically that means that I'm going to have to figure out when M is equal to 0, that means that N is equal to 100,000, which is B, divided by 10 to the 0 power. So that means that N is equal to 100,000. And then if M is equal to 8, because that's our domain from 0 to 8, then I'm going to go ahead and say that N is equal to 100,000 divided by 10 to the 8th power. And this is going to equal 0.001, which means that my answer is going to be 0.001 is less than N, less than 100,000. Number 12, a company's profit per year was found to be changing at a rate of dp dt equals 3t squared minus 8t. This right here is the derivative. where P is the company's profit in thousands of dollars and T is the time since the company was founded measured in years. Determine whether the profit is increasing or decreasing when T equals 2. The derivative is the rate of change. So one of the things that you can do is that you can substitute T is equal to 2 into the derivative. So if I go ahead and substitute, I get 3 times 2 squared minus 8 times 2, which is going to be 12 minus 16, which is equal to negative 4. So because the derivative is less than 0, since dp dt is less than 0, then that means that P is decreasing. Part B, 1 year after the company was founded, the profit was $4,000. Find an expression for P of T when T is greater than or equal to 0. So in this particular case, you need to figure out the integral. So for part B, you're trying to go backwards. They're giving you the derivative in the problem. You have to go back to figure out the original equation. So you're going to find the antiderivative or the integral of 3t squared minus 8t dt. Don't forget the dt. And then in order for us to find the antiderivative, then you're going to use the anti-power rule, which means that you're going to add 1 to the power and divide by that new power. So 2 plus 1 is 3, and then 3 divided by 3 is just 1. So this is t to the third power. When you don't see an exponent, the exponent is 1. 1 plus 1 is 2, so you divide by 2, and you're going to get, this is going to be minus 4t squared plus c. Because remember that you always have to put a plus c to stand for any constant, since the derivative of a constant is equal to 0. So how am I going to figure out that value of c? Well, I know that one of the points is 1, 4. Where do I get this 1, 4 from? They told me 1 year after the company was founded, the profit was $4,000. So T is the time since the company was founded. So that means when T is equal to 1, the profit, which is measured in thousands of dollars, P, is equal to 4. So I'm going to go ahead and substitute that information so that I can figure out my answer. So that means that 4 is equal to 1 to the third power minus 4 times 1 squared plus c. So 4 equals 1 minus 4 plus c. 4 is equal to negative 3 plus c, and c is equal to 7. So in order for me to find the profit equation, it's going to be P of t is equal to t to the third power minus 4t squared plus 7, and this is going to be my final answer for the 4 marks. And then finally, we get to the last question of paper 1, which is question number 13. A ball is dropped from a height of 1.8 meters and bounces on the ground. The maximum height reached by the ball after each bounce is 85% of the previous maximum height. Part A. Show that the maximum height reached by the ball after it has bounced for the 6th time is 68 centimeters to the nearest centimeters. So, in this particular case, one of the things that you have to realize is, number 1, this is an example of a geometric sequence, okay? You know that there is a pattern, and to go from one height of the ball to the other, you're basically going to be multiplying by 0.85. So the common ratio in this problem is 0.85, because after each bounce, you basically are going to maintain 85% of the previous maximum height. So you're starting at a height of 1.8 meters. Then the ball is going to drop. It's going to bounce. So when we talk about bounces, this height right here is the height of the ball after the first bounce. So right here we have this idea of an initial amount. Initially, the height of this ball is 1.8. But in terms of number of bounces, then U1 is going to be 1.8 times 0.85, which is 1.53. So the height after the first bounce is 1.53. And again, I figured that out because I took 1.8, which is the initial height of the ball before it bounced, and I'm going to multiply by 0.85, and that tells me that after the first bounce, then it's 1.53. And I can do this continuously for the second bounce, the third bounce, the fourth bounce. So this is a geometric sequence. In order for me to show this work, I'm going to write down that R is equal to 0.85, and my first term is going to be 1.53. In order for me to show that the maximum height reached by the ball after it has bounced for the sixth time is 68 centimeters, then that means that I'm going to have to do a geometric sequence formula where un is equal to u1 times r to the n minus 1. This is also in the formula packet. So in this case, I want to show that the sixth bounce, that the height after the sixth bounce is going to be the first term, which is 1.53. Remember, it is not 1.8 because 1.8 is the initial amount. So 1.53 times 0.85 to the 6 minus 1 power. So put this in your calculator. You're going to get 0.678869121. And I like to write all of the decimal values, and you should do as well, especially in a show that question. Remember, this is in terms of meters. So that means that this is equal to approximately 0.68 meters, which is 68 centimeters. So this is how you show that the maximum height reached by the ball after it has bounced for the sixth time is 68 centimeters. Now we go on to part B. In part B, it says, find the number of times after the first bounce that the maximum height reached is greater than 10 centimeters. So I'm going to set up the problem 1.53 times 0.85 to the n minus 1 power. That is going to be my geometric sequence, and I want this to be greater than 10 centimeters. And because the 1.53 in the problem, the 1.8 is in meters, so 1.53 is also in meters, then I need to make sure that when this is greater than 10 centimeters, I can put 0.1 because that's going to represent the same as 10 centimeters, 0.1 meters. So if I go ahead and I solve this, I can solve this in a graphing calculator. So if you go ahead and take your calculator, you can go to y equals and you can enter y1 as 1.53 times 0.85 to the x minus 1 power. And then you can go to second graph to take a look at the table of values. And there you're going to be able to tell that the answer is going to be 17. If you want to do this in centimeters, then the way you would set up the problem in centimeters is basically 153 times 0.85 to the n minus 1 is going to be greater than 10 if this is a case and you're going to do this in centimeters. So let me show you how this is going to look on the calculator. You're going to go to y equals, you're going to put 1.53 times 0.85 to the x minus 1 power, because it's n minus 1, but in the calculator when you use y equals, you're going to just use x. Then go to second graph, which is your table, and you're going to be able to tell the question says, when is this going to be greater than 10 centimeters, greater than 0.1? So notice, if you keep scrolling down, when is this going to be greater than 0.1? It is going to be after 17 bounces, okay? So the answer is 17. So once you're trying to figure out the number of times after the first bounce that the maximum height reached is greater than 10 centimeters, then that means 10 times. There are 10 times where the height is going to be greater than 0.1. So finally, it's time for the last question. It says, find the total vertical distance traveled by the ball from the point at which the ball is dropped until the fourth bounce. So they want the total vertical distance traveled by the ball. So that means right now the ball is dropped Okay, at that point, it's traveled 1.8. Then it's going to bounce 1.53 right here. Then it's going to go again 1.53. Then you can take 1.53 and multiply it by 0.85. And that's going to be the same amount going up as it is going down. So if I multiply, I get 1.3005. That is what happens when I multiply 1.53 times 0.85. If I do the same thing on the other side, 1.3005, and I multiply that by 0.85, then this third bounce is going to give me 1.105425. And again, this is going to match. This right here is going to be my fourth bounce. And again, on this side, it's 1.105425. So basically notice every single one of these is going to be double, except for the first one, which is you have to add the 1.8. So you can go ahead and do it the long way by just adding up every single piece. So another way that I can do the problem is that I can go ahead and work this problem out as a geometric series. Notice here on my first bounce, what I'm doing in purple, if I add it to the distance here and here, I can do that with a geometric series formula where the number of bounces is equal to 3. So in that case, S of 3, the sum of those first 3 bounces is going to be the first term, which is 1.53, times R, which is 0.85, to the n, which is 3 bounces, minus 1, all over R minus 1, 0.85 minus 1. Because the formula is Sn equals U1 times R to the n minus 1 all over R minus 1. So in this case, what I'm doing is finding just the purple. So if I go ahead and I get this answer from my calculator, go ahead and enter it in the calculator, I get 3.935925. But what I'm going to have to do is multiply that by 2. When I multiply that by 2, it's going to give me the other half, because obviously these are exactly the same height once it bounces and goes back down. But then I'm going to have to add the 1.8 only one time. So that means that I basically, for part C, again, the formula is Sn is equal to U1 times R to the n minus 1 all over R minus 1. We want to find the sum of what happens during those 3 bounces, which is going to be 1.53 times 0.85 to the third power minus 1 all over 0.85 minus 1. In the calculator, this is going to give us 3.9359, blah, blah, blah. And then from there, I have to multiply 2 times 3.935925 and add it to the 1.8, so that way I can get my final answer of 9.67185, which is approximately 9.67 meters. And that's my final answer, and that's the last question of the exam. Hope you found this very long video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence, and so that you can pass your IB exam. Until next time, thanks for watching.